Okay, year 11. So just to make sure that we can do exercise 14J, sketching sine and cosine graphs, which is, in my opinion, one of the hardest skills to take. So I'm going to try to take you through a few of the patterns that I do, and hopefully you pick up what to do. Okay, so in this particular case, I am not going to be teaching how I teach my year 12s, how I change the domain when there is a horizontal translation. So the ones I'm highlighting right now, these all have horizontal translations. Notice they're all different in the sense that they add, subtract, and not multiply. So unlike these are dilations. They change the period. Okay, they're stretches. All right, so even that 2 there, in fact, there's 2, 3, these are all dilations. Whereas what I've highlighted in yellow is translations. And I normally make sure that my year 12s get the domain correct. But in your case right now, just to get you practicing, we're going to just stick to the domain that's given. And unless there is a dilation, which is in green, then we will then change the domain. But we will not change it when we have translations, which is in yellow. Okay, so let's go with that to start off with. So I'm just going to work my way through the exercise. Let's pick a few to start off with so you can get a feel of it. I'd like to start off with whole numbers. Whole numbers are nicer, whereas you start off with the surds, it's a bit harder for you to picture what's going on. Okay, so let's do question 1A. Okay, let's do question 1A. So you got 1A. We are trying to sketch y equals to 2 sine of x plus 1, where you know x is between 0 and 2 pi. Okay, so here we go. Remember, I'm going to just list on the side the things that you need in order to sketch. You need to be able to show the max and minimum. Okay, so where's the highest point, where's the lowest point? You need to show the endpoints, which in our case, you've got endpoints at x equals 0, that's where it starts, and it finishes at x equals 2 pi. So you need to know where those endpoint coordinates are. So you need to find what y is and what y is for both points. You need to label x-intercepts, okay? And obviously y-intercepts as well. But those are your three main things that you want to be able to do when you're sketching. Those are the three things you must have, okay? Let's start off by looking at what we have. Okay, so I'm going to do it in green. We have an amplitude which equals to 2. That is determined by the value multiplied to sine function, okay, or cos function, and we can see that it's 2. Okay, so that's your amplitude. What does amplitude tell you? It just tells you from where the center is, okay, because when you draw a sine graph or a cos graph, which I'll show you, this is a sine graph. Here's the center. There is a center right there. That's the middle of the graph, where it splits the graph evenly in half. Okay, you got an upper half and you got a bottom half. Then the distance from the center to the maximum or minimum is 2. That's what the amplitude is doing. Okay. Similarly with a cos graph. So in a cos graph, then cos graph starts at the maximum and it comes down to the minimum and it comes back to the maximum again. Right? Then clearly again, same thing. Where's the middle? The middle is right here between 1 and -1. So between the top and the bottom here, it is still the middle there. Okay, so that's why we know this is your center. The height at which it takes to go to the maximum and minimum is 2. That's what the amplitude describes. Okay, and it's going to move this graph to the side so we can focus on what we need. So here we go. We got amplitude equals 2. let's read what we have over here. We have the +1, which hopefully from chapter 7 other exercises we've done, we know this means up 1. In this case here, it is not moving left or right. You can already see that it's just x equals to 0. Inside the brackets, it's just x equals 0. And how do you find the period? The period is based on the coefficient or the number multiplied to x, which in our case, the only number in front of x right now is 1. So we know that the period, which is given by 2 pi divided by n, and we know that n is equal to 1. So what does that tell us? That tells us that the period is 2 pi. Okay. Now, like I told you, I said that the tip that I want you to take is that we are going to find the quarter period. So quarter period. Okay. So quarter of the period. Quarter of the period. So that means if the period is 2 pi, then the quarter of that is divided by 4, and that tells me that every quarter cycle or quarter period would be pi on 2. What does this mean? So just in case those who missed out on my lesson, when we draw, I want to draw a sine graph because it's easier to see. Okay, when we draw our sine graph, this is pi, this is 3 pi on 2, and that's 2 pi, right? What you can see is you have these special points, which I'm going to color in red. You started at 0, which is the starting point, and then you reach the maximum at pi and 2, because sine of pi and 2, remember this is sine of x, sine of pi and 2 is equal to 1. Or if you think about the unit circle, see by the time you get to this first quarter, see quarter of the circle, you get to pi and 2 sine, which is the y values, it reaches a maximum of 1, which is here. Okay. After that, you do another quarter part of the circle, then sine now reaches at this point, which is sine, which is the y values, is 0, which makes sense that you end up 0 for your y values. Okay. Then you do another quarter cycle, and you find that actually now your y values is right at its maximum value, which is 1, but it's in the negative direction, so that's why you reach -1, which is down here. Okay, which is why it's 3 pi and 2, because you've gone 3 out of 3 halves is what you've done. Okay, so you got 1 half, 2 halves, 3 halves. Okay, and finally you reach the final end, and you reach back at 0 again, because at that point y value is 0. So that's why you land here. So there are 4 special quarters here. You've got the 0 to pi and 2, that's 1 quarter, 2 quarters, 3 quarters, and then 4 quarters. Actually, that doesn't make sense. I meant as in like 2 pi divided by 4, and then, yeah, you know what I mean. So pi and 2, pi, then 3 pi and 2, and then 2 pi. So you get your quarters there. Okay, so quarter, 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 which is why we call them quarter cycles. Okay. So what's special about these quarter cycles is that the sine graph repeats these quarter cycles. So it goes from the center to the maximum, to the center again, back to the minimum, back to the center. And it's every quarter. So I know next one, if it was 2 pi, which is, what's that? 3 pi on 2, that's 4 pi on 2. Then the next one's 5 pi on 2 to reach the maximum. After that, it would have to be 6 pi on 2 to reach the center. And then the next one has to be 7 pi on 2 to reach the minimum. And then the next one has to be then 9 pi, or 8 pi on 2, sorry. 8 pi on 2, which makes sense. That makes it 4 pi. So you get the second cycle. Yeah, so the first one was a period of 2 pi, and then you go for another one that's a period of 4 pi. So you can see that if we can find that distance, how far it takes to make a quarter cycle, so this distance here, this distance here, distance here, if you know the quarters, so 1 quarter, 1 quarter, 1 quarter, 1 quarter, you can continue those dots where you get the maximum, minimum, and you get the center. You can picture what the graph looks like. Okay, so what we've just figured out is the quarter period is pi and 2. That's the distance. Okay, so Now let's go back to our problem. So here we go, we're back to this problem here, and we are going to try to sketch very roughly, because remember there are three things I need. I need maximum, minimum, endpoints, and x-intercepts. Okay, so here we go. I'm going to draw. So here we go. So I've got, what we need is, we need to know where's the center. The center, usually for a sine graph, would have started at 0, true, but I've shifted up the graph by 1. Remember, it was up 1. So I want to move the center up 1 now. So this is where the center is. It's at 1. Okay. And from there, remember, I'm just going to do some dotted lines here. If this is the new center, instead of it being on the x-axis, that's the new center. It's gone up by 1. Okay, it's gone up by 1. Then now to find the amplitude, you told me well, we found the amplitude was 2. So that means that to get to the maximum now, the maximum 1 plus 2 would have to be 3. Okay, that's the only way to get the maximum with amplitude 2. Okay, so from 1 to 3, that's a distance of 2. But by the same concept, from 1 to go down, then this would now mean that 1 take away 2, or technically, if you remembered, another way of thinking about this as well, if you prefer, remember how when we drew our sine graph that you started off with 1, okay, if that's, sorry, yeah, maximum was 1, and you know the amplitude is 2, well then now you know that it would be 1 plus 2. Similarly, if previously the minimum was at -1, then now it's -1 plus 2. Okay, because we know that we're shifting the graph up by 1. Okay. Now, I'm just trying to remember why that doesn't seem to make sense. What have I done wrong? Amplitude is 2, and you shift up by 1. So it should be -1 for this spot here. So this is -1. Here we go. So we got, this is your minimum and your maximum, which is at 3. So that makes a distance of 2 and 2. Okay. So remember the amplitude here, we know that it would have been -2, but since we're moving up by 1, so -2 plus 1 gives you -1, and 2 plus 1 gives you that 3 as well. Okay, so now we've got our upper end and bottom end. So you can see that, so these are the lines that I'm going to use as a guideline to sketch. Okay, so now I'm going to look at it and I'm going to say, all right, so I only shifted the graph up by 1. I didn't move it left or right, so I started here. What I need to know is if I started at 1, which is this point, I'm going to do in red, then the sine graph, we know that sine graphs have to go to the maximum next. Remember sine graph, when we go back to our sine graph, remember right here, the next point is the maximum. So I'm going to go to the maximum, but how far is it to go from 0 to the maximum? We figured out the quarter cycle, which was pi on 2. So I know this has to be pi on 2. Okay. Then that means I know that the next point to go back to the center has to be another pi on 2. So pi on 2 plus pi on 2 is pi. Then after pi, then I know that, or another way of thinking about it is 2 pi on 2. Then the next one has to be now 3 pi on 2. Okay, which hits the minimum. Then after that, it has to be then 4 pi on 2. Okay, which gives you the maximum there. Now 4 pi on 2 is technically 2 pi, and remember our domain was between 0 and 2 pi. So here we go, I've got my graph here, and it goes up, comes back down, and back up, and it finishes there. Okay, and it just so happens that this, as we're doing this, we happen to have calculated our endpoints when x is 0. Clearly the y value is 1. And when x is 2 pi, clearly the y value is also 1. It just so happens that this is an easy graph. The only thing I'm now missing is my x-intercepts. Okay, so if I were to sketch this graph now, I'd say, okay, well, the x-intercepts, how do I calculate that again? We've got y equals to 2 sine of x plus 1. find x-intercept, let y equal to 0. So I'm going to let y equal to 0. So here we go, 2 sine of x. And this is going back to exercise 14H. Okay, so 14H, I'm going to minus 1 on both sides. 2 sine of x, divide both sides by 2. You get sine of x. And then I need to find sine inverse of negative half to find x. Now remember, at this point here, it's not just one simple answer because there are infinite answers. You need to use the domain, which is working between 0 and 2 pi. Okay, and so I taught you for exercise 14H that we're going to use the unit circle to figure this out. So the question is, sine, what does it represent? We know it represents the y values, but when will the y values be a negative half? Clearly negative half is here. That's your y values, where the y-axis, where half is your y value, and the only way to get a y coordinate around the circle where it's equal to negative half has to be these two quadrants. So it has to be here and it has to be there. The problem is I just don't know. Though I know that the sine is the y value, which is this height, I know it's half, this triangle here that I'm drawing, I know this is half, right? What I don't know is what the angle is and how far is it for the radians. Okay, that's what I don't know. I don't know the radians. So here we go. We're going to use our exact values and we're going to say, all right, well, sine of what will give you half? And this is where you can look at the tables, or you can look back and say that in order to get half, sine of 30 degrees, which is actually pi on 6 distance, will give you half. And then also this is the same thing as 30 degrees on this side, or pi on 6 down. Okay, so to answer the question from here, then going around the unit circle, I'm going to do it in black. You can see I start at 0 because we start at 0. I'm going to move around the unit circle. I'm going to move until I hit negative half as one of my y values, which is right there. Now we know all the way up to here is pi, and then I need an extra pi and 6. I'm going to write down my first solution. Pi with an extra pi and 6 will give me my first answer. And then I continue around the circle until I finish my cycle, which is at 2 pi. But remember, I hit another solution here, and that's just short by pi and 6. Okay, so 2 pi losing pi and 6 will give me those two particular answers I want. And I finish at 2 pi. Okay, so my answer so far, x is equal to pi plus pi and 6. So 6 times pi is 6. 6 plus 1, 7 pi and 6. The next one, 6 times 2 pi, which is 12. Take away 1 is 11 pi on 6. Okay. And so there we go. So that's my 2 x-intercepts there. We can say that going back here, this is 7 pi on 6. And we know that this is 11 pi on 6. There you go. And that I've labeled my coordinates. I've got the x-axis intercepts. I happen to have my y-intercept. I have the maximum, minimums, and the endpoints. So that's my graph there. Okay, obviously when you actually do it later on, you won't need these green dots that I'm doing here. I'm doing it just so that you can see how I'm picturing the graph. Later on, you're not going to use these dots, or if you do use them, do them in Gradlet and rub them off. That's essentially what you'll need to do. Okay, so I'm just rubbing it off so you can see what it should look like as your final answer. Your final answer should have been maximum 3, 1, and -1. There you go. That's my graph for the first one. Now I know it feels like that was a lot of effort. Keep in mind, I'm also explaining as I'm doing this. So in the next video, in the next example, I'm also going to do the others now quicker. Okay, I'm going to show you what I'm doing, and hopefully you pick up on what I'm doing. Okay, this first video.